Hi all, this is Mr. Yeager. This topic now we're looking at half-life. It's the second part of the nuclear, short nuclear unit. Again, I'm sure that you probably have seen half-life before in a prior class, but we're just basically doing the same thing again. So again, half-life, symbol T1/2, is the time it takes for half the substance to decay. I mean, it's kind of right in the middle of the terminology there. So the shorter the half-life, the more unstable the atom is. So again, what we're referring to here is how quickly that object changes into another form, how quickly some of those nuclear reactions occur, how quickly they release radiation. The shorter the half-life, the more radiation that they're continuously releasing because they keep on changing into something new, a new element completely. So we just need to be able to calculate these, and I mean there's essentially a few different types of problems in terms of how to calculate it, but I kind of try to go through a very systematic approach for all of them. Okay? So if we just jump straight into it, probably the classic example would be that you have this element X has a half-life of 2 minutes. If you have 20 grams of element X, how much is left after 4 minutes? All right? And I'll tell you, we will only do problems where every time it'll come out to a nice number. It's not going to be one where you only have half of a half-life occurring. What happens? That's not what we're interested in. We're not interested in any form of equations that basically get into logarithms and exponential decreases and stuff like that, which is much more difficult. This is a very standard, just let's half it all the time. So again, we're looking at just breaking this down in half. So the big thing that we have to do is we have to identify what we have, okay? So right at the very beginning, it tells us we have a half-life of 2 minutes. So T1/2 is equal to 2 minutes, okay? You have 20 grams of element X, so this is basically the initial mass, 20 grams, okay? How much is left after 4 minutes? So we're looking for final mass, and we have total time, which I'm just going to call TT, 4 minutes, all right? So what we do, and the way I like to look at these primarily, and I mean there's different ways you can go about it, is every problem is going to be giving you these 4 things we're basically looking at. It's just going to give you 3 out of the 4. Like another problem could give you the initial mass, the final mass, and the total time and say what's the half-life. So I like to look at these all basically the same. And since we're just dividing it by 2 or multiplying it by 2 depending on which way you go, I like to look at it basically in this form where I write out how much do I have? 20 grams. Okay, I have 20 grams. And then I draw a little arrow. Basically, each arrow in my setup here is a half-life occurring. So what I can do is obviously there's multiple ways you can go about this. You can go ahead and write in after 2 minutes, I'm going to be down to what's half of 20? 10. Okay? So after 2 minutes, I'm down to 10 grams. The thing is, how many minutes go by? 4 minutes. So basically after another 2 minutes, and that's where I think people get confused because they write 4 there, it's every 2 minutes we half the amount. So 2 minutes go by, 10 grams is left, and another 2 minutes go by, 5 grams is left. What is the total time that has gone by? 4 minutes, and so I'm done. That's it. Okay, I have 5 grams left over. That's my final answer. It's not 4 minutes, but 5 grams. Okay. Another way that some people, if they just don't understand that, where it's just okay, just keep halving it until you run out of time. Okay, is you could go through it and go, the number of half-lives equals the total time by the half-life. So you could do it this way where you go, okay, well there's 4 minutes, 2 minutes is the half-life, I'm going to have 2 half-lives. What does that mean? I'm going to cut my 20 grams in half 2 times, 2 separate times. Okay, so 20 to 10 to 5, there's my answer. That's fine too, but I like to use the arrows is basically my method in terms of solving these. But, I mean, we just have some other examples. Just going to go through a couple different ones. You have 100 grams of element Y. Okay, so there's your initial mass. If there is only 12.5 grams left, that must be my final mass. After 12 minutes, how long is the half-life? So is 12 minutes the half-life? No, it's the total time. Okay? How long is the half-life? For this one, I love doing the arrow technique, where basically you're just trying to figure out how many times do I have to half to get down to 12.5. So what I do is I go 100 is going to go to 50. After that's one half-life. After another half-life, it's 25. And after another half-life, hey, I made it, 12.5 grams. So how many times did you halve it? You halved it 3 times. That means there must have been 3 half-lives. Well, what's the total time? 12 minutes. Well, let's divide that by 3. There you go. Each half-life is 4 minutes. Okay. Next. Element Z has a half-life of 5 minutes. If only 1 gram is left after 20 minutes, how much element Z did you start with? All right. So for this one, they give you the half-life right away. They give you the final mass, and they tell you the total time. So sometimes people go, oh, this one's so much more difficult because I don't know what I start with. What you're doing is you're starting at the end. I'm at 1 gram at the very, very end. Okay? So I need to figure out how many times I need to go backwards. How many times I need to double. Because each time I went this way, I half it. If I want to go back, I double. So I have 20 minutes the total time. 5 minutes is the half-life. So 20 divided by 5, there must be 4 half-lives. So therefore, I'm going to double it once. I'm going to double it again. So that's 2. I'm going to double it again. That's 3. And I'm going to double it one more time. 16 grams. So my answer is 16 grams is what I started with. Okay. I think the only example I'm not showing is, what did I show? I showed it total time. I mean, I think the only other example would be, yeah, if you're solving for total time. So they would give you the half-life, the initial and final amount, and say how long did it take. So again, pretty straightforward. All right. The only other thing with half-life is they love to give you the half-life curve, and it is always this curve shape going downward, basically toward the 0 axis. It will never reach the 0 axis because you can't half the 0. But the idea is that you keep on having that element every single half-life. So they'll usually give you a graph, and they'll go, the questions would be, the primary question would be, what is the half-life? What you do on this is start at some amount. So in this case, I'm going to say, okay, I'm going to start at 100. Well, what's half of 100? It's 50. So at 50, as it goes from 100 to 50, that would be 1 half-life. So in this case, I made it nice and easy and said, hey, look at that. It must have taken 5 seconds. And if I keep looking, after another 5 seconds, I half it to 25. After another 5 seconds, I have it to 12.5, etc., etc. I mean, if it doesn't line up perfectly, sometimes I just say, the other question would be, how many half-lives occur to get to 6.25, or how much is left after 3 half-lives. So it goes back to your initial question, but the main idea is I have people they get so scared of graphs, and graphs are usually much easier questions because all the information is given to you. Just start out at some amount. I didn't have to start at 100. I could have looked at 50 and said, what's half of 50? 25. Oh, here's the data point. What's the difference in time? 5 seconds. That must be the half-life. All right? So try not to overcomplicate those things in terms of graphs. They're not that difficult. Okay? Thank you.